In this video, we're going to evaluate this indefinite integral of 1 over x times the square root of x to the fourth minus 1. Now when you're working these types of problems, if you see the procedure that you need to use right away, then great, you go for it. But if you don't see it, then you have to kind of look at the integrand and see what comes to you. Obviously, if you have a rational expression, you're thinking of partial fractions, decomposition. If it's a rational expression, but it's not in simplest form, the degree of the numerator is larger, then you think, hey, let's go ahead and divide the denominator into the numerator and then take it from there. Or you might have an integrand of trig functions. So you think of some of your identities. How can you manipulate the integrand to get it to a point where you can use a certain identity or a certain substitution? Sometimes it's radicals. You think a lot of the U-substitution. Let U equal to the radicand or let U equal to the entire radical. Now in this particular case, the look of this particular integrand here kind of reminds me of some of these inverse trig functions or integrals leading to a inverse trig function. We'll look at this particular one. This is a standard formula that your instructor probably would expect you to know, or if he lets you use some cheat notes, one formula that you would use on a test, assuming he gives you that opportunity to use your notes or use a sheet of formulas that he might provide you with some of the formulas. But anyway, this is the integral here that I'm looking at here. Have the integral of du over u times the square root of u squared minus a squared. That gives you 1 over a arcsecant. Well, that's the same thing as secant inverse of absolute value of u over a plus your constant of integration. So go back to the original. This one is not quite there. But let's do this. Let's multiply the numerator and denominator by x. So multiply by x in the numerator, I'll get an x dx, and multiply the denominator by x also. That'll give me an x squared, x times x, and then the square root of. So now we have an x squared over here. Now we look at the radicand here, and let's do this. Let's rewrite that x squared, or x to the fourth rather, into x squared, and put it in parentheses, and then square it. Get minus 1. And then from this, remember the formula I'm trying to come up with here. I want it to look kind of like that. So in order to do that, I want this here with the x squared, I want that to be a u. So let's let u equal to x squared. Then we can go ahead, alright, take the derivative, differential here, du equal to the root of x squared is 2x. Now we get the dx here. Again, we're transforming the integrand into something we can use. Another formula, integration formula. So then up here, then let's convert this to the u variable. So I got x dx right there, and I got an x dx in the numerator. Let's divide by 2. Both sides by 2. So that tells me then that x dx can be replaced by du over 2. So I'll put the 1/2 out in front. And this would just be du up here. And now let's go through this. X squared, okay, so that's the substitution u. So this is just going to be u. And that's the square root. Then here we'll have the x squared squared. X squared is u, so this will be a u squared minus 1. Now it looks just like the formula that I want to use here. This then should equal constants out here. Remember, if I had the constant here inside, you can work it out. As long as it's constant, you can put it out in front. So this is going to be 1/2 then. And then now we're looking at this right here. That's exactly what I just showed you at the beginning of the video. So the valuation of this integral then is going to be secant inverse, or we can write it as arc secant of the absolute value of u, but u is x squared, so x squared is never negative, so I don't need the absolute values there. I just put x squared, and it was over a. So in this case, a is 1. 1 squared is 1. So this is over 1. And then it was also, the a also divides the coefficient here. But that's still going to stay 1/2. 1/2 divided by 1 is still going to be 1. So this could be plus a constant. So let's rewrite this. 1/2 arc secant of x squared plus your constant for integration. This is your solution. Thanks for watching. We'll see you next time.